Assalamualaikum and good day. Welcome back to BQS 552 Construction Technology 4. In this class, we will continue on Chapter 3, Earth Retaining Structures. Let's recap on our last week lesson. We have learned what is Earth Retaining Structures. We also have covered a few types of gravity walls under mass construction. We learned that there are 5 types of retaining wall for mass construction, which are concrete with masonry facing, unreinforced masonry, gabions, and creep retaining wall. For this week, we're going to continue with the semi-mass construction and reinforced construction. Apart from that, we're also going to learn about reinforced soil walls and hybrid walls. For semi-mass construction, it is comprised between simplicity of mass concrete and low material content of RC. It can be cost effective if RC details are kept simple and the use of reinforcement is little. This is the example of semi-mass construction. As you can see, the retaining wall is made from concrete with a little bit of reinforcement. For the third type of gravity wall, we have a reinforced construction, special type of gravity wall. The stabilizing weight is applied by the weight of the restraint material resting at the base slab. Jadi dekat base tu akan diletakkan the materials yang kita nak restrain. So it helps to stabilize the walls. Pressure can be reduced by widening the base slab either at the back or front of the wall. Dekat depan atau kat belakang, base tu akan lebih dilebarkan lah. The following are the main types of wall. We have the concrete cantilever, counterfort or buttress, precast masonry, and pre-stressed retaining wall. Concrete cantilever wall or stem walls of reinforced concrete are the commonest type of gravity wall. They are composed of vertical or inclined slab, sengit sikit monumental with a slab base. Simple form of cantilever wall utilize the weight of the earth or backfill on the bottom. So this is the backfill yang kita letakkan. It is placed on the top of the base of the wall. This weight is added to the concrete weight to provide resistance against active thrust. Because of soil ni pun ada weight, jadi dia akan help to stabilize the retaining wall overall lah. Simple to construct and permanent joint are easily arranged. This is what we call the stem and the base. And at the back where the retained material locate, kat sini lah namanya heel. Yang kat depan, bahagian depan retaining wall adalah toe. And we have the concrete blocks. This one lah, dia dibuat dari concrete. And ada juga reinforcement. This large flexural stress at the base of stem ni, flexural stress tu adalah bending stress. So bending stress banyak terjadi dekat this area. That's why this area is a bit thick compared to other parts of the retaining wall. This is the photos of concrete cantilever wall. This is the stem part and this is the slab base. This is the cross section of concrete cantilever wall. As you can see, this is the horizontal part, the stem. This is the base of the retaining wall, and this is the beam. Okay, and this is the hardcore or rubbles as filtering materials to whip holes. Provided juga ada lean concrete blinding, okay, to at least protect the base ni daripada the soil below. Cantilever wall can be designed in many ways lah. Okay, this is the typical format where you have the base part is bigger at the back maksudnya base part tu lebih kat belakang compared to dekat front wall, and the second one most part of the base berada dekat depan, the front of the retaining wall, or maybe almost at the center between the base and also the stem. Jadi base ni duduk tengah-tengah lah. This is the example of the construction of cantilever walls. As you see, the base is done. Okay, jadi concreting untuk base dah siap, and the next part they will concrete for the stem punya area. This one also the construction of cantilever wall. So this is the mold for the stem part of the retaining wall. The second type of reinforced construction is counterfort or buttress wall. Counterfort wall are cantilever walls. This is basically a cantilever walls with counterfort monumental. So this one is counterfort monumental with the back of the wall slab and base slab. The counterfort act as a tension stiffener and dia connectkan between the wall slab ataupun stem ni dengan base of the wall. Counterfort are used for high walls with height greater than 8 to 12 meter. If it is needed to provide wall yang lebih tinggi, counterfort ni lebih sesuai lah sebab kalau compare dengan normal cantilever wall, this wall lebih sesuai lah untuk construction of wall yang lebih tinggi. This is the typical cross-section area of counterfort or buttress wall. Actually, dia lebih kurang sama lah macam cantilever wall, it's just that dia ada this counterfort. Okay, dekat bahagian belakang tempat retain material tu ada this counterfort. The next type of reinforced construction, we have a precast concrete retaining wall. These are manufactured from high-grade precast concrete on the cantilever principle, usually to a 600 mm wide module. So different dia bukan cast in situ, it is a precast concrete retaining wall. Can be erected on a foundation as a permanent retaining wall or be freestanding to act as dividing wall between heap materials such as aggregate for concrete. The units are reinforced on both faces to meet all forms of stem loading. This is the typical cross-section area of precast concrete retaining wall. As you can see, this wall, horizontal part dia a little bit battered sengit sikit. And kalau dia permanent structure, kita akan fix holding down bolts lah pada foundation. And sebab dia adalah precast concrete retaining wall, so lifting nak fix is required, jadi kena ada holes lah untuk letak brackets and so on, so that kita boleh lift dia and fix dia to the location yang kita nak. This is the installation process of precast concrete wall. As you can see, this wall is lifted by crane untuk diletakkan pada position dia. Ni dia punya karakteristik lah. Okay, it needs to be bolted down. It is cast in, heavy duty, and can be freestanding also. The next reinforced construction, we have reinforced masonry retaining wall. Steel reinforcement may be used in brick retaining wall to resist tensile force and to prevent the effect of shear. So this kind of wall, dia pakai brick tapi ada additional reinforcement. A brick bonding arrangement known as queta bond is used to create a uniform distribution of vertical voids. So, cara dia susun brick ni pakai queta bond. Vertical steel distribution is tied to the foundation reinforcement and space to coincide with the purpose-made voids. When the brickwork is completed, the voids are filled with concrete. Jadi bila brickwork ni dah complete, RC dah kita letakkan kat dalam ni, kita akan fillkan this void dengan concrete. This is the typical cross-section area of reinforced masonry retaining wall. Dia ada foundation and this is the actual wall yang dibuat daripada brick, reinforced dan konkrit yang dipor dalam lubang-lubang ni lah antara brick ni. Apart from the gravity walls, we have reinforced soil walls. There are two types, which is soil nail walls and reinforced earth walls. And we're going also to look at the difference between these two. Reinforced soil walls are used as an integral part of the design, as an alternative to the use of reinforced concrete or other solution on the ground of economy or as a result of the ground conditions. It also can be used for temporary works and as remedial or improvement works to an existing configuration. This category cover walls which use soil reinforced with reinforcement elements to provide a stable earth retaining system and include soil nailing and reinforced earth. Soil nailing is a stabilization method of reinforcing existing soil by installing threaded steel bars into slopes or cut as wall construction proceed from top down. Jadi dari atas ke bawah. Grouted bars are installed to create a stable mass of earth. It is the first step in building a solid wall. The nailing process creates a single block of earth able to hold back its overburden. Soil nailing is an economical means of creating shoring system and retaining walls. Often, nailing is less disruptive than other means of construction. Working from top downward, a mass of reinforced soil is gradually built up. In order to keep the soil from caving in between the bars, some sort of facing needs to be installed. This is generally made with some shotcrete reinforced by a welded wire mesh. This facing can be vertical, battered to a wide variety of angles, or made up of series of benches. The passive bar are often referred to as nails, and the soil reinforcing technique is known as soil nailing. The construction of reinforced soil walls include the soil is first excavated, depending on the ability of the cut face to remain vertical without support. Holes are drilled along the cut. Jadi dia akan berlubang lah tanah ni ya. Threaded steel bars are inserted in the hole. The length of the bar is a function of the soil type, but it is approximately half the final depth of excavation. The bars will protrude a few inches out of the hole. So, bar ni akan terkeluar sikit lah, beberapa inch. The holes are grouted with concrete. Welded wire reinforcement is placed over the wall and tied to the protruding bars. Jadi kat sini akan ada terlebih bar yang terkeluar dan ada welded wire reinforcement yang diletak kat depan ni. A layer of shotcrete is applied to a mesh. Shotcrete is actually a special mix of high strength concrete yang dia spray with the high velocity on the wall using compressed air. Nanti dia akan form retaining structure. Plates and washers are inserted to the protruding bars and locked in the position with the nut. A second layer of shotcrete may be used if the soil nail wall is a finished wall, or a cast-in-place concrete wall may be constructed against it. These steps are repeated with the next depth of cut. Jadi dia semakin ke bawah sebab kita buat dari top down. Jadi turun lagi ke bawah, potong lagi sikit tanah, and then akan repeat balik the same process. This is the process of drilling the hole pada tanah ni Reinforced earth walls. Mechanically stabilized earth walls are structures which are made using steel or geosynthetic soil reinforcement, which are placed in layers within a controlled granular field. The combination of reinforcement and earth create composite structure which is internally stable as long as sufficient reinforcement are placed within the earth to counteract the shear forces that result when soil is placed at 90 degrees angle of repose. Jadi ada friction dekat sini. Reinforced earth consists of soil, steel strip soil reinforcement, and precast concrete facing panels. Other systems utilizing different facing system, for example, wire and concrete masonry blocks, and different soil reinforcement type, such as welded wire mesh, geogrid, or geotextile. The construction of reinforced earth wall is different from soil nailing. First, the panel will be installed first. Jadi dia tak ada excavation Kita install dulu panel ni. And then kita akan backfill aggregate dekat belakang panel tadi. Okay, as you can see kat bawah ni memang dah ada geosynthetic reinforcement ataupun, and then barulah this reinforcement akan di-attach pada panel ni. If needed, nak tambah lagi level, next layer of panel akan di-install. Jadi dia akan install layer by layer the panel tu, so that the construction tu dari bottom to top. Jadi dia lain daripada the previous method. Of reinforced earth wall yang dah siap lah. So inilah contoh panel yang ada dekat market. The difference between soil nailing and reinforced earth. A soil nail wall will have been built downwards, with the soil being reinforced in situ. Jadi kita akan bina dia, construct top to bottom. The soil will be excavated by layer, and then kita akan buat soil nailing. Moreover, it is in situ because kita akan pakai shotcrete untuk attachkan soil nail. Compared to the reinforced earth, kita akan build dulu the panel. We don't excavate soil. Takkan excavate, tak usik pun. Kita bina je dulu panel, and then we must know that kita kena letakkan lah that soil reinforcement, and then pour the aggregate untuk backfill bahagian belakang panel tu, and then kita akan tiekan that reinforcement pada the panel, the back of the panel. Okay, this is the simplified explanation of typical retaining wall. The first one is gravity wall. So how actually the force react pada this wall The earth pressure akan push retaining wall ni untuk overturn. However, gravity akan help to stabilize the retaining wall. While piling, there is also active earth pressure at the back and passive earth pressure from the front. While for the cantilever wall, the active pressure from the retained material, and we have the gravity from the wall And also the weight of the soil on the top of the base will help to stabilize the wall. While for anchored wall, we have the active earth pressure acting at the back of the wall and the reaction from the anchor here yang help to stabilize the retaining wall. Next, we're going to look at the pile retaining wall. Pile retaining wall are constructed by driving reinforced concrete pile adjacent to each other. Bersebelahanlah antara satu sama lain. Pile are forced into a depth that is sufficient to counter the force which tries to push over the wall. It is employed in both temporary and permanent works. Pile walls offer high stiffness retaining elements which are able to hold lateral pressure in large excavation depth with almost no distribution to surrounding structure or properties. Jadi pile sangat kukuh lah, dia punya stiffness dia is quite high dan surrounding structures ni takkan tereffect disebabkan oleh this pile retaining wall. This is the example of reinforced concrete pile retaining wall. As you can see, this is contiguous for pile. Ini pun samalah jenis dia. Next, we're going to look at sheet pile walls. Sheet pile walls are walls constructed by driving steel sheets into a slope or excavation area. Their most common use is within temporary deep excavation. They are considered to be most economical where retention of higher earth pressure of soft soil is required. Sheet piles ni actually adalah continuous board inserted into ground as earth retaining structure. It will support the earth pressure and also will keep the water out of an excavation area. Sheet piles are normally dibuat daripada timber, steel ataupun RC. For depth up to 15 feet, vertical sheets or steel referred to as sheet pile can be driven to the ground before commencing excavation. Sheet piles consist of individual steel sections that interlock with each other on both sides. The interlocks form a continuous barrier to retain the earth. Structurally, sheet piles function as cantilever and therefore must be buried into the soil for sufficient depth below the bottom of excavation. Jadi mesti ditanam ke dalam sebab kalau tak, dia tak akan stable lah. Sheet piles are also used permanent barriers against water, for example for harbour walls, flood protection walls and many others. Coffer dam pun boleh pakai sheet piles. Sheet piles are available in many cross-sectional profiles. Tapi yang most common adalah Z section like this one. The sections are driven into the ground by using either hydraulic hammer ataupun vibrators. For deeper excavation, generally greater than 15 feet dalam, sheet piles are braced with horizontal or inclined braces or anchored with tie backs. Sama ada dia akan anchor dengan tie backs macam ni ataupun dia pakai braces like this ataupun incline like this. Sheet piles are removed after they are no longer required and can be left in place if needed. So dia boleh jadi permanent ataupun temporary wall. So this is the traditional sheet pile shape. This is the most common, which is the Z section as I tunjuk sebelum ni. Flat or straight, Larsen ataupun U-type ataupun arch shape like this. This is the typical types of interlocks, meaning that between sheet piles ke sheet piles perlu di attach together, jadi kita akan pakai this kind of interlocks. Jadi adalah cross section lah macam mana actually the sheet piles look like ya. So there's a walls here. Walls. Actually dia macam batang besi yang dia letak horizontal pada the sheet piles untuk you letak struts ataupun bracing dekat tengah ni. Okay, this is the example of temporary sheet piles use. For example, mungkin nak buat coffer dam. It is enclosure that installed in soil or water to prevent ingress of soil or water into the working area. Jadi sheet pile ni dipakai untuk avoid water daripada masuk kawasan ni sebab kawasan ni nak di construct something lah. So we need this space to be free from water. Next, we're going to look at the hybrid walls, which have the tie-back anchor walls, tailored gabion, tails, concrete blocks, and sheet pile walls. For hybrid system, any wall which use facing units tied to rods or strips or any of the material which have their ends anchored into the ground is a hybrid wall. These are walls which combine elements of both externally stabilized wall and internally stabilized wall. So we have tie-back anchor wall, tailed gabion and tailed concrete block. And another one is sheet pile. Tapi sheet pile tadi I dah explain on the one yang ada anchor kan. Jadi sheet pile pun kita boleh anchor dia ke dalam tanah. So it's also called as hybrid system. For the first hybrid system, which is tie-back anchor wall, tiebacks and tie-downs can be installed in a virtually any ground condition using rotary, percussion, or down-the-hole hammer tooling. The critical design elements are the capacity length of unbonded zone, corrosion protection, ground cover, and testing specification. In the construction of tiebacks, bars or cables are placed in a pre-drilled hole with concrete grouts. Cables are commonly high-strength, pre-stressed steel tendons. Jadi dia akan pakai tendon. To protect the tie rod from corrosion, it is coated with paint or asphaltic materials supaya dia tidak cepat berkarat sebab dia akan expose pada mungkin water dalam tanah tu sendiri. Next, we look at the tail gabions. Gabion wall element fitted to geogrid tails extending into supported soil. As you know, gabion walls ni dia adalah basket yang diletakkan broken stone. The first structure on record to use a combination of gabions and mechanically reinforced soil was built in Sabah. The vertical skin of gabions can be anchored to the backfill using metal strip. Jadi kat belakang ni, in between the gabion basket ni, ada metal strip yang dia akan anchor pada backfill dekat belakang tu. Belakang yang kita nak tahan tanah tu. So this is the typical section. Okay, we have the gabion structure which is the bucket that filled with the crushed stone ataupun broken stone, and we have the mesh reinforcement. Ini dia mesh reinforcement ataupun metal strip tu lah, and ini semua adalah compacted stone. Satu adalah untuk drainage and dua sebenarnya adalah untuk this mesh reinforcement akan sit in between that compacted soil, jadi dia akan ada friction yang help untuk tie dia ke belakang, anchored dia to the belakang ni. Other type of hybrid system, we have tail concrete blocks.
Concrete block facing unit. So ini adalah dia punya facing panels fitted with geogrid tails extending into supported soil. To aid the anchorage, the end of the strip are formed into a shape designed to bind the strip at the point into the soil. This is the example. So ini adalah strip dia. Kalau you nampak dekat belakang ni ada aggregate. Jadi aggregate yang kasar-kasar ni dia akan provide friction yang akan anchor this strip pada this aggregate. We have reached the end of the video. Thank you for your kind attention. I will end the recorded video with the quote from the world-renowned theoretical physicist. However difficult life may seem, there is always something you can do and succeed at. Thank you so much. Have a nice day. Bye.